Today you're going to graph hyperbolas and also write the equations for hyperbolas. So in order to graph a hyperbola, you're going to need to determine if the hyperbola is horizontal or vertical. And in order to do that, you look at the terms. If the first term has an x, the hyperbola is horizontal. And when it's horizontal, the parabola wraps around the x-axis. So the foci are always inside the branches. Remember, these are called the branches of the hyperbola. If the first term has a y, the hyperbola is vertical. So it's going to look more like this. Again, the foci are inside the branches of the hyperbola and it wraps around the y-axis. So you'll need to find the center of the hyperbola because everything is measured from this point. You need to identify A and B, and just like the ellipse, A, not A squared, but different from the ellipse, A is always the first denominator. In an ellipse, A is always the largest denominator, so keep those two things straight. B is always the square root of the second denominator. Now with an ellipse, B was always smaller. Okay, you need to identify C, and again, this is another difference between the ellipse and the hyperbola. With a hyperbola, A, B, and C are related by adding A squared and B squared together. In an ellipse, you subtract A squared and B squared to get the C squared. Okay, here is our first hyperbola, and we're going to graph it. The center is at 3, -5. Now just be careful. If you have something, let's say, I'll just write it up here, y plus 4 squared minus x plus 3 squared, and you don't have to write this down, then our center is going to be at -3, -4. Look for x, the x coordinate with the x, look for the y coordinate with the y. Okay, so we have to decide if it's horizontal or vertical, and you decide that by which numerator, by looking at the numerator. If x is first, and this is just for the hyperbola, then it's going to be horizontal. So this one is horizontal. Our center is going to be at 3, -5, and A is going to be the square root of the first term. So here A is 3. Now again, on an ellipse, A was the largest, but with a hyperbola, A is the first one. So that means now we're going to have to add and subtract 3 from the x-coordinate, from and to the x-coordinate, I should say. Okay, so if we add 3, we're going to get 6, -5. If we subtract 3, we're going to get 0, -5. All right, now B is going to be the square root of 49. So that's just going to be 7. And since it's underneath the y, that's what we have to add and subtract to and from. So if we add 7 to the y coordinate, -5, we're going to get 3, -2. And then we subtract 7, we'll get 3, -12. Okay, let's just graph all of this first here. We need to graph at 3, so 2, 3, this is a scale of 2, and then we're going to go to -5, so 2, 4, this is our center, and then our vertices are at 6, so 2, 4, 6, -5, and 0, -5. And I'm just going to put V's here. The reason why I'm putting V's here is because the branches of the hyperbola always have to go through the vertices. And if you just start plotting all the points, you may forget which one are the vertices and the co-vertices. So the co-vertices are at 3, -2. Well, let's see. That's 3, -12. This should be 3, +2. Right, because we're adding 7 to the -5. So this is a +2. Change that to +2. Okay, so that's going to be 3, +2. and 3, negative 12. Oops, slide it over here. Okay, and these are the co-vertices. Okay, once you do that, you can make the box for the graph, and we're just going to make dotted, and you probably can't see that very well. Let me change it to pen here. We just make dotted, and we're making a box through the co-vertices and the vertices. All right, now we're going to graph the foci. So first we need to do c squared is going to equal 9 plus 49. So c squared is going to equal 58. So C is going to be approximately 7.6. All right, so we're going to add 7.6. Now remember, the foci and the vertices are always on the same axis, and with a hyperbola they're always going to be on this first axis. So we need to add to the x coordinate, and you'll be able to see if you put the foci in the wrong spot once you go to graph it. So the foci are going to be at 10.6, negative 5, and negative 4.6, negative 5. Okay, so we've graphed the co-vertices, we've graphed the vertices, and let's graph the foci here at 10.6, negative 5, and negative 4.6, negative 5. Okay, so these are the foci. All right, now you want to find the slopes of the asymptotes. If x is first, then the slopes of our asymptotes are going to be plus or minus b over a. So the slopes of our asymptotes are 7 over 3. So plus or minus 7 over 3. Now, you're going to do this from the center. Everything's measured from the center. And instead of just drawing these, this is a good way to check to see if you've accurately graphed your vertices and co-vertices, because what should happen is that when you go up 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, you're going to end up in the corner of your box. So that's just like a double check when you go over. Now let's go back up here. 1, 2, 3, 4, 5, 6, 7, over 1, 2, 3. And sometimes students just draw the box and then they draw in the asymptotes, but just take a couple seconds to count to make sure, that's like a double check, that the slopes of your asymptotes do in fact go through the corners of your box. So the asymptotes again are going to be dashed. And hit it through the center and the corners of your box. Okay, now once you get here, you need to pay attention to which ones are the co-vertices and which ones are the vertices, because the branches of the hyperbola have to go through the vertices and they have to wrap around the focus, and it has to touch the vertex, so don't leave them out here like this. So when you come along here, your branches need to hug right along your asymptote, and then actually it could go a little closer here, and then through the vertex, and then it's going to come back out and go along the asymptote, not crossing over them. So when you graph this, don't make your, don't just go like this. I'll probably take off for that, because those asymptotes are like guidelines. They tell you where the branch needs to be graphed. Okay, so then if we go over to the other side here again, through your vertex, and then right up alongside your asymptotes. Don't go inside the box though. Okay, so that's how to graph. Now we're going to write equations for the hyperbolas, and you are going to need the center, of course, because everything's measured from the center of the hyperbola. You'll also need A and B, and then this can be crossed off here. That's really all you need. You don't have to have the slopes of the asymptotes. You just need those when you're graphing. Okay, so we have two different examples here. The first one, we have a center at 0, 0. We have a vertex at 4, 0. And let's change this to a focus at 10, 0. So we'll make that into a 0. Okay, if you don't know what to do, always a good idea to draw a quick sketch of the information that you're given. So we'll just do this here. And when you do that, label what you have. Don't just put the points on. So here's our center. Our vertex is at 4, 0. So I'm just going to go here, 4, 0. That's my vertex. My focus is at 10, 0. So I can come over here to 10, 0. And that's my focus. All right, I need A and B. I know that A represents my vertex. So A is going to be 4, centers at 0, 0. And now we need B. So what we have is A and C. So we're going to go use C squared equals A squared plus B squared. So that's going to be C squared would be 100. A squared would be 16 plus B squared. And then if we subtract 16 from both sides, we're going to end up with B squared equals 84. Now I'm just going to put the square root of 84 here and not simplify it because we really need B squared for our equation. Okay, so we have a center at 0, 0. So we know that we have this hyperbola has to be set equal to 1. Okay, now we have to figure out if it's vertical or horizontal. Now since the vertex is on the x-axis, it has to be horizontal. So the x comes first, and it's at 0, 0, so we don't have to add or subtract anything, so that's going to be squared. Then we know the y comes next, and we have to subtract in between. So underneath the x, since it's on the x-axis of 4, we square that to get 16 under the y. And then under the y squared, we just put 84. Okay, now I also want you to be able to write the equation for a hyperbola when you're given a graph. So this graph is horizontal, so we know that we're going to have the x first and then the y. We have a center at 0, 0. Now A represents the length from the center to your vertices. So your vertices are going to be right here. I'll just put a V here and a V here. And then these are going to be your co-vertices here. So CV, CV. All right. Now the distance from the center to the co-vertices, this is a scale of 2, 4, 6, 8. Okay. So we have on our vertices, it's at 6, 0 over here and negative 6, 0 here. So we know that A is 6. Make that purple just to color coordinate it. And then on our co-vertex, we have 2, 4, 6 as well. So this is going to be 6. All right, so our equation, we don't have to add or subtract anything from the x or the y, and we know it wraps around the x-axis, so x has to come first. So we have x squared over 36 minus y squared over 36 equals 1. Now I want you to look at these two equations. Yesterday I told you that in a hyperbola, A could be bigger, so A is always first. It could be bigger than B, which is right here. It could also be less than B, or it could be equal to B, which is what we have right here. Now that won't happen in an ellipse, because if the denominators are equal in an ellipse, you're going to have a circle. Okay, so you have a few questions to try on the next page.